Somehow, I ended up with another British treasure. This time a Royal 10.5 inch or 250mm metric shaper. The motor you're seeing here isn't the one that came with the machine. I've quickly thrown this single phase motor in, just so that I can easily plug the machine into the wall and see what moves or crashes. This is a 15 amp high precision Swiss made specialist machine switch. Okay, let's see what happens. And well, there we are, it's alive. It seems to more or less work. But this motor is a little fast for the machine, so I'll need to sort something else out. But at least it didn't explode. This is the motor that came with the machine. It's a 3-phase 1200 RPM Hoover and the original switch. I have no idea if this motor runs. When I purchased the shaper, the 3-phase cord had been cut. Let's see if the motor runs if we wire it into a basic variable frequency drive. I'm sure most of you guys have seen these before. Basically they can run off single phase power, but output 3-phase. I haven't inspected this motor at all, just hooked up the wires, and we'll see what happens the fun way. The original cord may have been cut for a reason. Odds on for smoke. She's trying. Yes, here we go. Was that a banshee? Probably need to fix the screeching before we go any further. I think this sticky old grease might have something to do with the screaming. I guess the bearing spun in its housing. The old grease is tacky like tar. Some fresh grease is probably all it needs. Let's try that again. She's a little shaky in patches, but otherwise seems to run fine. Let's jam her in the machine. It's convenient that when the German engineers installed this switch, they held it in place with hot glue. Chinese single phase out, and back in goes the Hoover. One day I'll sort this shaper out properly with nice remote switchgear. But not right now. Right now, I'm going to hang the VFD off the side of the machine with a few strips of aluminium. Now, there's a little bit of a story to tell here. The motor didn't run when it was driving the machine. Well, it did, but not with enough torque to move anything. You motor guys will know exactly what the issue is. But wait! There is nothing on the motor that actually says 3-phase. The nameplate is illegible, and I've never seen this machine run, nor had the previous owner. This cover plate shows a single-phase diagram. That caused a couple of hours of confusion, but it turns out that Hoover are just a bunch of funny pricks, and this diagram has nothing to do with the motor it's attached to. And of course, the issue is just that there are two ways to wire a 3-phase motor, for high or low voltage. It just had to be changed from star to delta, as the pros would say. And with the 3-phase Hoover all sorted, the shaper runs like a champ. I decided to stick it on a mobile base. One of the kit-set bases woodworkers like. I know it's not ideal for a shaper to be rocking around on a flimsy base, but I've only got a small, non-dedicated garage to work in. The shaper can't permanently occupy the centre of the floor. As you can see, it is a little flimsy, but long term I'll probably just use this base as the base for building a more steady base. For now it'll do. Now, where were we? Oh yeah, I took the motor out again. I decided it was a little too shaky, and I wanted to experiment with balancing it not properly. Modern phones actually have pretty decent gyroscopes in them, and there are plenty of free apps available to spit vibration data out. You can probably see where this is going. This isn't my idea, and it's not a new idea. Basically, we stick weights on each number in turn and record the amount of shaking. Don't ask me what units we're actually measuring. Smaller is better. Here you can see the results. The top line is without weight. Position 1 was slightly better, but position 4 was the standout, 2.1 Zs. So now that I know that the best spot is somewhere around 4, we can refine that position more accurately. And once we find the sweet spot, adding or subtracting the amount of weight until it feels smoothest. More by feel than measurement at this point. It actually feels pretty good. I think I'm ready to stop playing with the motor now. So now that we have a smooth running, wobbly on its feet shaper, the only problem left to solve is the clutch. I've never used one of these machines before, and information is thin on the ground. Well, thin on the internet. But I'm pretty sure you shouldn't have to stand here holding the clutch lever out like this. The clutch is adjustable. Hopefully that's all that needs doing. I quickly took the cap off to look for any obvious faults. Nothing apart from a broken washer. You can see how the mechanism works. The cap is pulled inwards by the lever on the other side of the machine. Presumably it should stay engaged if the clutch is adjusted correctly. Once a little pin is released, the inner ring can be turned to tighten or loosen the clutch plates that sit within the outer spline that makes up the hub of the pulley. The adjustment is making a difference to the engagement point of the clutch, but not really solving our problem. I think I've got it figured out now. These little wheels that I've freshly greased, as they are pushed in, they engage the clutch. But also the whole assembly, including the wheels, slides in and out as well. I think what is happening is that we are engaging the clutch by sliding the whole assembly, but not getting past the point where the wheels squeeze in. Here's the inside of the cap. You can see there is a ramp that the wheels are supposed to ride up. My guess is that they are not getting past the top edge of the ramp, and so press the cap back out as soon as I stop pulling on the lever. So what's the conclusion? Well, I reckon stop being feeble and pull on the lever like I mean it, and hope nothing explodes. Ah, that's it. I did have to pull on it pretty hard, but nothing was actually broken, just a little stiff. I guess it'll get better with use. And there we go. No hands. Enough faffing about. Let's carve some metal. The only clamps I have are these little M6 straps that I made for the Myford. The shaper will take M10 studs, but these will do for now. And check this out. Courtesy of so many people wanting to electroplate stuff with vinegar, I decided I could splurge on a fancy new screwless vise. This is my tool. Oh yeah, and this is the really convenient stroke adjustment. I think most of the small shapers are like this. You just sort of guesstimate the stroke you need by moving this brass slide. Metric! And hoping like hell that nut doesn't come loose. 254mm is all good. 255 equals crash. Now that we've set the stroke to about 100mm, we need to position that stroke relative to the ram of the shaper. That 100mm stroke can happen anywhere from way out at the edge of the table to right under the nose of the machine. We obviously want the range to cover our workpiece. Alright, I think we're ready to go. I've turned the machine by hand to check for explosions. Seems fine. So let's carve some chips. Better use cutting oil. And first cut. Did you see it? This isn't a restoration project, yet. Just an introduction to Viceroy, the Royal shaper.